I got friends in New York City, 'cause everyone I know left town.
Slide, basically. So what we just found was cosine squared theta plus sine squared theta is equal to 1. And this is so special because it is called, that it has a name, and it's called the Pythagorean identity. Okay, and it's called Pythagorean because it kind of derived from the Pythagorean theorem of like relating the sides of a triangle, right? And it's called an identity because it's true for any angle theta that you pick, okay, or that we are using. Okay, so the useful thing about this is that if we know cosine, we can figure out sine. We can find sine of that angle right away, okay? And vice versa, right? If we know sine, then we can just plug it into this equation here and figure out our cosine. So here's an example. It says if sine theta is equal to 3/7 and theta is in the second quadrant, find cosine of theta. Okay, so let's kind of just ignore what the second quadrant is saying for now, and then we'll try to figure out what is cosine supposed to be. What are its options? So we can use the Pythagorean identity, right? Because we have this relation between cosine and sine. So if we know one, we can figure out the other. Alrighty, so we know sine, so we can just plug in 3/7 for the sine spot. So this is going to be 3/7 because that's sine theta. And then we're going to square it because that's the formula according to the identity, right? Now I'm just going to solve for cosine of theta. So cosine squared theta plus 9/49 is equal to a 1. And then if we just subtract that over to the right side, we get 1 minus 9/49, which is equal to 49 minus 9/49 is equal to 40/49. Okay, so now we have cosine squared theta is equal to 40/49. To solve for cosine theta, we just square root both sides. So this is going to be equal to plus or minus the square root of 40/49, which is the same thing as saying plus or minus the square root of 40/7, and we can also take out a 4 there, or well, a 2. So 2 times square root of 10/7. So now the thing is, okay, well, which one is cosine? Like, is it positive or negative, or is it both? What's going on? And this is where we use the information that theta is in the second quadrant, okay? And again, here are the quadrants, so here's quadrant 1, 2, that doesn't look like a 2, 2, 3, and 4. And the thing is, for the second quadrant, our x values are negative, right? So x values are negative, y values are positive, and since cosine corresponds to kind of like x, then we can say, okay, so cosine is going to be negative, right? Because our x is negative. So we're just going to pick the negative value. So cosine of theta is equal to negative 2 radical 10/7. Okay, so now let's visit what's called the unit circle. Okay, unit meaning whenever you see the word unit in math, it usually means something has a length of 1. Okay, so in this case, the unit circle has a radius of 1. Okay, so radius of length 1. Okay, which is nice because 1s are pretty simple, right? So let's say we have this unit circle, right? And we have something like this. Okay, our circle there. Alrighty, and the radius is 1 everywhere on this circle. Okay, so it crosses at 1, 0, 0, 1, all this stuff. So this is all length of 1 all the way around. Okay, and normally what we have is that our x, y points can be translated into r cosine theta and r sine theta. Okay, remember that's because we found x is equal to r cosine theta, and y is equal to r sine theta. Remember, we just kind of rephrased those formulas that we found, okay? So in this case, though, because we're dealing with a unit circle, then each xy point translates to simply 1 times cosine theta, because our r is 1, right? And sine theta, okay? Which is nice, because then from here, whatever values we get for theta, we can kind of just say, okay, so for that angle, our cosine is going to be this, or our sine is going to be this, blah, blah, blah. And then we can apply that to different circles as well, okay? So, let's start off by saying, okay, what if our angle were pi over 4? Okay, and pi over 4 corresponds to saying 45 degrees. Okay, that's like halfway in your first quadrant there. Alrighty, so if we have an angle of that, so here's our theta there, then we have the following ratios. So we have this triangle that's formed where we have something like this. That's a pretty good line. Not that one, but anyway, so we have a triangle that's formed like this. This is 45 degrees, okay? This is 90 because we just dropped it straight down. This is also 45 degrees. And we know that the radius has a length of 1, okay? So the thing is that we have now a 45, 45, 90 triangle, right? So this should be, this hypotenuse should have a relation, or its ratio to the side legs, or the lengths of the legs, should be square root of 2. So we have hypotenuse over leg. For a 45, 45, 90, that should be a ratio of square root of 2 over 1, right? So if our hypotenuse is 1, so let me write that again. So if our hypotenuse is 1, right, and then over our leg is equal to square root of 2, then our leg, if we just switch things around, just switch the positions of those, we get 1 over radical 2 should be equal to the length of our leg. Okay, so that just means 1 over radical 2 is down here, 1 over radical 2, and this is also 1 over radical 2. Okay, and we can always simplify that in order to say, like, not simplify, sorry, rationalize. So if we take this guy, and I'm just going to write this on the next slide so we have more room. So we're going to take this triangle. This is a, though it might not look like it, 45, 45, 90 triangle. So we have 1, and we found out that the side lengths are 1 over radical 2 and 1 over radical 2, and they're the same length, right? So if we were to take the sine of, let's say, this angle here, we get sine of 45 degrees. That's going to be opposite over hypotenuse. So that would be 1 over square root of 2 over 1. This is equal to 1 over square root of 2, and we can rationalize this by just multiplying times this square root on both top and bottom. So we get square root of 2 over 2. That's what sine of 45 degrees is, okay? And that's going to be constant. That's true at all times. Sine of 45 is always going to be square root of 2 over 2, okay? Now let's find cosine. Cosine of 45 degrees should be x over r, so that would be this guy over this guy, which is actually going to turn out to be the same exact thing. Kind of funny, right? So this is going to be equal to square root of 2 over 2 as well, okay? So now we have that, and so for our 45, 45, 90 triangle, also, you could just say for 45 degrees or pi over 4, we're always going to have that cosine of 45 is equal to sine of 45 degrees is equal to this square root of 2 over 2, okay?